Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 12B Part 1 assignment. First one we're going to take a look at here is number 1. When a manufacturer makes X items per day, the profit function is blah, 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 pounds. Find the production level that will maximize profits. So, as you can see there, this is a negative quadratic. So, basically, it's going to look like this here, right? And we're going to look for that maximum point up there. So since this is a calculus unit, I'm sure what they're wanting us to do is go through and if we find the derivative, then we can set that derivative equal to 0, because remember the derivative gives you the slope at any point along the function of the tangent, right? The slope of the tangent. And if the slope of the tangent is 0, that means it's a maximum or a minimum. So that's what they'll want us to do. We'll also take a look at it on the graphing calculator because you can do it that way as well. So if we do the derivative here, p prime of x is negative 0.044x, and that's x to the first, times, so plus 11, subtract 1 and that's gone, and then that's gone too. So we can take that and we can set it equal to 0. So we know, because again, this gives us the slope at any point along the line of the slope of the tangent line. Okay, so if this, we want to figure out when is the slope of the tangent line at 0, because that will be a minimum or a maximum. Okay, so we'll do 0 equals negative 0.044x plus 11. So we subtract 11 from both sides. Negative 11 equals negative 0.044x. So we'll divide both sides by negative 0.044. And that will tell us how many items we need to make. Okay? Okay, so I'm not even going to bother putting the negatives on there because the negatives will cancel out. So 11 divided by 0.044 gives us 250. So we want to make 250 items per day to maximize our profit. Okay? Now, again, you could also do this same problem here on the graphing calculator if you just put the original equation in, negative 0.022 x squared plus 11 x minus 720. Okay, so the tricky part here is when you go to graph this, who knows what our window was. Let's see if we have, let's do zoom. Let's see if we're at zoom standard, let's say, and we go to graph this thing. Good chance that this will not show up anywhere. So what we have to do is once you get good with the windows, like switching stuff around, then a lot of these questions will become pretty quick and relatively painless. But let's see, we know our x is the number of items we want to make, so we know we can't make less than 0. And then maximum, let's say we don't know that it's 250, so I just put in, say, 1,000 just to kind of check. And then the scale really doesn't matter. That's just how often they put little lines on the graph. And then y minimum, we could have a negative, you could end up losing money. And then maximum, we're like making money on all these items here. I'm going to maybe put in, like, say 10,000 and just hope to see what happens. So there's our graph. That's enough to find the maximum. Just for good sake here. Oops, I keep pushing the wrong button. Second zoom. Nope, just plain old window. That's what I wanted. My max, it was barely, you could barely just see the blip, so let's just turn that back into 1,000 instead. And then that just looks a little nicer. So all we got to do there is just find the max, right? So second trace, find the maximum, number 4. And then it says left bound. Let's see. Right now we're at 500, which is over here. So we got to go back until we know for sure that thing's on the left-hand side. Right, so there it is on the left. Push enter, scroll back over, get to the right. It's definitely to the right of it. It's going to check for the highest y value between those two lines there, and we get 250. And then the y happens to be 655. So if we were to plug 250 back into this original equation here, we'd get 655. And that's how much money you're making according to this model here. Okay? All right. Moving on to number 4, a duck farmer wishes to build a rectangular enclosure of an area 100 square meters. Farmer must purchase wire netting for 3 of the sides, as the 4th side is an existing fence. Naturally, the farmer wishes to minimize the length and therefore the cost of fencing required to complete the job. If the sides adjacent to the existing fence have length X, show that the required length of wire netting to be purchased is this. So, let's see, we got a nice little space over here. Let's do A over here. So, basically what we got is we've got an existing fence here, right? And then what we're going to do is we're going to put this new fence on. This rectangular area here. We'll put that on to get our new set of ducks in there, right? So it says if the adjacent sides to the existing fence have to be X meters, so that means these here are both going to be X, show that the required length is blah, 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 blah. So we know that we want this thing to be 100 square meters, right? So we don't know what this length is over here just yet. We can call that, I guess, y for now. So we know that x times y has to equal 100, right? Okay, so since we know that those two have to multiply together to get 100, we can actually figure what y is in terms of x, because we can divide both sides here by x and say our y has to be 100 divided by x. So instead of y, we'll get 100 minus x. So then now to come up, so now the, let's see, 100 over x, not minus x. 100 over x. So we now know the length of all of our fence here has to be the 2 x's. So length equals 2 x's plus 100 divided by x. And if you'll notice, that is the same thing as that. So just saying, how do we come up with that? That's how you come up with that. B, find the minimum value of L and the corresponding value of X when this occurs. So we want to get the lowest fence amount. So what's X have to be in order for this fence amount to be the lowest here? So what we'd want to do here, so we're going to want to take the derivative of this here and find out when our slope equals 0, right? That's going to help us find in this case, our minimum amount, right? So we've got, for part B here, we got L equals 2x plus 100 over x, which is the same thing as 100x to the negative first, right? So the derivative is going to be 2, and then negative 1 times 100 is minus 100. Subtract 1 more from that, x to the negative second, or minus 100 over x squared. That's our derivative. So we want to know when this is going to equal 0, right? So we simply just do 0 equals 2 minus 100 over x squared. I'm going to subtract, it'll be negative, but that's all right. Subtract 2 from both sides. We get negative 2 equals negative 100 over x squared. We multiply everything by x squared. And then we're going to get negative 2x squared equals negative 100. Divide both sides by negative 2. X squared equals 50. So that means x is going to have to equal the square root of 50, which you can just leave it as the square root of 50. But if you want to know what the square root of 50 is, 7.07. Okay, so that means in order to get this 100 meters squared, we want these sides here, the x's, to be 7.07 meters. And then that means that this is going to have to be 100 divided by 7.07. So 100 divided by, and we'll even do this, second answer is 14.14. So this length here is 14.14. So that's going to give us the minimum value. That's when x equals 7. So really the minimum value is going to be all of those added together. So that's 7.07, 7.07, 14.14, and that is going to be this. Let's see. 14.8, 28.28 meters of fencing is going to be able to give him or her the 100 square meters of fenced-in duck park that they want. All right. Sketch the optimal situation showing all dimensions. There's our, that's all in red here. Find the minimum value of L. That is actually right here, this 28.28, and the corresponding values of x when this occurs. So that's what we did first. We figured out that x had to be 7.07, so then this side over here had to be 14.14, so forth and so on. Okay? All right, let's take a look at one more, and that is number 10. Athletic track has 2 straights of length L and 2 semicircular ends of radius x. Perimeter of the track is 400 meters. Show that the length is going to have to be 200 minus pi times x, and write down the possible values that x may have. Okay, so we know that this whole length around the track's got to be 400 meters, right? So let's do this. We know that 400 meters has to equal, there's an L over here as well as over there, so 2 lengths plus, we've got half of a circumference here and the other half here, so we know that the circumference of a circle is going to be 2 pi r. Okay, so I'm going to do 2 lengths plus 2 times pi, and our radius in this case is not r but x, so we get that. And then all we want to do now is solve for L. So I'm going to subtract 2 pi x from both sides. And we get 400 minus 2 times pi times x equals 2L, right? So divide both sides by 2, and we get that our length has to be 400 divided by 2 is 200, and negative 2 pi x divided by 2 is negative pi x, and that's our length, which is exactly that right there. And then it says, and write down the possible values that x may have. Okay? So we know that this length has to be greater than 0, and our x also has to be greater than 0, right? So we know that our length is 200 minus pi x, right? So we know that this 200 minus pi times x has to be greater than 0. Okay, so if we want to solve for x here, we would, let's do this. I'm going to add pi x to both sides so that I don't have to mess with since I'm not multiplying or dividing by a negative, I don't have to mess with my inequality. So 200 has to be greater than pi times x, so we divide both sides by pi, and we get that x has to be less than whatever 200 over pi is. So you can leave it like that, or you can actually come up with what 200 divided by pi is. There's pi. And that gives us 63.66, so we'll call that x has to be less than 63 point, what did I say? 63.66, so 63.7. Okay? So x has got to be less than 63.7, but it also has to be greater than 0, so those are possible values that x may have. Okay? All right, this is all we have for part of the work problems here on 12B Part 1. If you have any further questions, please feel free to ask. Thanks.